Whew. Not too much to actually talk about. Nope. Should really be putting together research. Uh, Although there's a big old physics textbook that I should be reading instead. Um, no, I've actually been thinking more about kind of like current projects. There's like lots of news around not living forever, but very greatly extending how long that people live, uh, as far as from a perspective of transferring consciousness to alternate mediums. This requires a lot of data, um, because there's lots of people who define consciousness in lots of different ways. So there needs to be lots of data to make sure that the environment is appropriate. Um, yeah, so lots of materials involved with that. So lots of with yay quantum technology. Yeah. Uh, um, the impact on uh, chem movements. So uh, moving both biochemical and just naturally occurring chemical objects via quantum uh, mechanisms or programs. Uh, yeah, so basically just having a very precise movement and control of uh, important chemical things. So yeah, all the algorithms exactly need to be collected as far as like what's popular, and then also yeah, just what's popular, like, so that's where the data comes in, um, as far as like widespread data. Uh, so yeah, that's been one focus, it seems. So um, let's talk about communications in our atmosphere, like physically. Also, xenon propulsion, electromagnetic propulsion, xenon. Those guys know how to uh, use waves for very small processes that happen on large scales. They might have at least one part, well, data regarding the process of these quantum algorithms that I was talking about earlier. So with that process and on a very scientific level, um, yeah, if that process is understood, then you do a lot of cool things. Um, so with respect to telecoms in our atmosphere, um, that's where terraforming comes into play. Uh, I've been a fan of terraforming just because of environmental reasons. Kind of leads me to the electromagnetic propulsion. Aside from, I'm not sure about the cost of xenon extraction or sourcing as opposed to some other fuels. Um, However, um, I would assume it's less costly, but that's not really something I know too much about. Yeah, yeah, more the process and security on that small of a scale, and then translating that into something that isn't in such a mechanically controlled environment for terraforming. And when I say terraforming in this scenario is more of um, uh, separating communications of between um, the process for controlling the environment. So to avoid destroying, creating holes in the atmosphere from communications or data relaying. So that's a pretty cool process that I don't know anything about. Um, so it's on my to-do list is uh, not focusing on carbon destruction of the atmosphere, but on protecting against communication disturbances. So, um, what else? There's a xenon propulsion rockets. I think will be a big help with that. Um, Getting people familiar with that technology of the xenon propulsion, the electromagnetic propulsion, and then being able to clearly see the lines between uh, like which energy is exerted uh, into the atmosphere, into Earth's atmosphere from a xenon propulsion rocket, and versus what is exerted from data relaying from like telescopes uh, and countless other scientific instruments uh, that are outside of Earth. So, like I said, seeing those lines between the transportation, the pure data, and then the what's used for communications for just projects that are local in the atmosphere, and then like FAA lines and like transit lines, and then you have your consumer navigation, which is like Tesla also FAA, kind of weather data, you know, that section. So you have all of these things happening. So just to see the effect on the atmosphere's composure. So imagine a bunch of people sending up tons of satellites and rockets through the atmosphere. How do you stop a big hole from forming? In other words, how do you make sure that we don't send all the oxygen in our atmosphere and nitrogen and whatnot flying into all different sorts of directions because we obviously don't want, we're not fueling our rockets with all with just with the atmosphere. So unless our xenon extraction is currently from the atmosphere, if our xenon extraction is from the atmosphere or if our xenon extraction, I'm sure it's both from solid materials and from airborne materials. But making sure that environmental protection is there. So as far as like, yeah, no, I've been working on like materials, IDE, materials and designing for like actual consumer spaceships, and like onboard fueling systems, things like that that aren't necessarily appropriate because of the environmental impacts of current missions, current processes, that can be easily cleaned up. So, yeah, then we can get to like the onboard stuff because it's really, if you introduce certain systems into, if we put an onboard fueling system, chem extraction, atmospheric chem extraction onto your spaceship, and you just set it up in your parking lot, and you or garage or whichever, which is actually where the materials comes into play, and infrastructure for that commercial space vehicle would be concerned. But if we set up some sort of airborne chemical extraction, you wouldn't be able to just implement that because of current atmospheric problems. So once you have like a stable understanding of that, then it's like learning to extract from a little bit, from a different bunch of different environments. So like extraction from an asteroid while in transit, specific chem extraction, and this specific the precision of this instrumentation requires quantum understanding of like algorithms on a quantum level, just like quarks make up atomic particles, just like that basic understanding of like there's charges on extremely small levels can very greatly impact a process when it comes to extracting chemicals from the air, especially in transit. When there's tons of things moving in the air while you're also moving, or throughout space while you're also moving, you need precision movements for an extraction equipment or a filter system. A filter system would actually, I mean, both, but a filter system on a quantum level, though. If you're going to be extracting a chem for your vehicle, you want a quantum filter. um, let's see. Yeah, so but that can't all happen on one planet uh, because then you're just gonna eat away the atmosphere, and so you need to like learn how to design that equipment to extract something from a solid or a gaseous body, or different easily accessible space environments from a commercial vehicle. Uh, that might be like some sort of uh, nearby exoplanets atmosphere, depending on how strong the gravitational field is. Uh, which really that's really yeah, that's how strong your gravitational fields are in nearby uh, settings. So yeah, don't forget about the uh, current environmental standards. I'm not sure where that. I guess does the EPA still exist? I'm sure it does. As far as the environmental standards go, well, I have not looked into those, so that's where I should be right now. Um, Again, the precision, the terraforming is going to come after the environmental standards, but it's kind of a first first step in from what I've looked into. Into the process of terraforming or atmospheric manipulation as opposed to just maneuvering about the atmosphere for some purpose. This would actually require the manipulation of the atmosphere for protective purposes. Yeah, there's definitely gonna have to be a lot of like regulation about that process, just because I don't think it'll take too long to get that going if it's not already. I'm sure everyone has their every channel that I was just talking about has their own uh, procedures, and so just to collectively turn that into one agency, then like they'd have a pretty good sense on terraforming procedures, just laying down the basics, the law, uh, the basics. So brush up on physics and comm. And I'm gonna probably get into like IDEs, like for materials. It would be nice. That so. All right.